Hey, good morning. Hi, we're going to look at something percent composition. Pretty simple. Make sure you have your periodic table and your calculator. All right. And I'm going to share my screen. Do that here. Share, hold down, share. And baby steps. Remember, this is just filling in the spaces, right? Need to get this in here. And it will lead into something else. So we're going to look at the simple concept of percent composition, right? And we're doing this basically in terms of compounds, okay? So what we know, let's see, whenever you need to get a percentage, right? Any percentage is the mass. We're going to get the percent composition by mass, all right? And that is going to get, we'll have a little formula. Percent comp equals the mass of the element over the mass of the compound, right? Anytime you want to get a percentage, basically you take the piece and you divide it by the whole, and then you multiply it by 100, right? All right, so we're going to get the percent composition of compounds. The pieces there are the elements and the wholes are the compounds. Let's just do an example, all right? Let's do the percent composition by mass of H2O. Okay, so what I see here is there's two elements in this compound, so I will have two answers. All right, my first answer will be the percent hydrogen by mass in the compound. I usually teach this in the beginning of the year. This is a different year. The second element is oxygen, so I'll have percent oxygen by mass in the compound. So what I will not do, and I hope that you do not do, is add up the number of atoms of hydrogen and divide it by the total number of atoms, or add up the number of atoms of oxygen and divide it by the total number of atoms. This is a percent by mass, so I will have to use my periodic table. All right, so let's get hydrogen. All right, I've got two hydrogen atoms in this compound. Each has a mass of 1.01 grams. Periodic table. That gives me a total of 2.02 grams of hydrogen in 1 mole of this compound, all right? Oxygen, there's one atom of oxygen, each weighs 16.00 grams, so I have a total of 16.00 grams of oxygen in 1 mole of this compound. That gives me a total of 18.02 grams of the compound. So the percent, let's go down, let me get rid of that. I like to work down, right? The percent hydrogen is equal to the 2.02. Let me slow down. Is equal to the mass of H divided by the mass of H2O times 100, right? And this is the mass of H in the compound. So we've got that. The percent hydrogen will be equal to our 2.02 grams divided by the mass of the compound, which will be our 18.02 grams. So out of the 18.02 grams, 2 grams is hydrogen. All right, well, what percent is that? And that's easy. 2.02 divided by 18.02 equals, boom, times 100. That is 11.2% hydrogen by mass. Notice how pretty the label is and how nice and neatly my work is shown. Okay. Oxygen, we can do two things. I can take the mass of the oxygen, which we have right here as 16 grams, and divide it by the mass of the compound. And that's going to equal 88.8% oxygen by mass. Okay? Okay. Notice that these add up to 100%, right? I've got to account for everything. Okay, let's do one more. C6H12O6. All right. All right, and we need to calculate its percent by mass. We will have three answers: carbon, hydrogen, oxygen. For our carbon, right, we've got 6 carbons. Look at your periodic table. Each has a molar mass of 12.01. All right, 12.01 times 6 equals, that is 72.06 grams of carbon. For hydrogen, I have 12 times 1.01. What's that? 12. I just had a brain fart. 12.12, yeah. 12.12 grams of hydrogen. And then for oxygen, we've got 6. Each oxygen has a mass of 16.00 grams. 16 times 6 equals, that is 96.00 grams of oxygen. Let's add those together. 96 plus 12.12 equals plus 72.06 equals, I have a total mass of 180.18 grams of the compound. All right, so I'm going to do this slightly differently. No. The percent carbon, I'm not going to do it differently, is equal to the 72.06 grams of carbon divided by the 180.18 grams of the compound. So the percent by mass of carbon in this compound is, looks like it's 40. Yep, 39.99. All right, we'll keep it at 39.99% carbon. Let's get our percent hydrogen, right? So from a percent hydrogen, I'm going to look up at my hydrogen. I've got a total of 12.12 grams. And I'm going to divide it by the mass of my compound, which is a total of 180.18 grams. I'm going to multiply that by 100 to turn it into a percentage. And I should expect a very low number because 12 is a very small percentage of 180. In fact, it is 6.73%. We're just going to keep the two numbers after the decimal, okay? Hydrogen, some of you might be cringing. Maybe I should have wrote 6.727% hydrogen, right? In terms of sig figs. I'm not going to worry about sig figs in this problem. But, you know, there you go. And then we will have our percent oxygen, right? We will then take the mass of our oxygen and divide it by the mass of the compound. So percent O is equal to the 96 grams of oxygen divided by the mass of the compound. Or some of you may be thinking, well, couldn't we add those other two percentages up and divide and subtract it from 100? And I would say, yeah, you could. 96, this looks like it should be a little bit greater than half, right? Divided by 180.18 equals times 100. Yep, that would be a 53.28% oxygen by mass. All right, now let's apply this. First of all, we have three answers. We now know that, pay attention here, if I have a sample of C6H12O6, 39.99% of that sample will be carbon in terms of its mass. Not the atoms, but the mass. 6.73% of the compound's mass will be due to hydrogen, and 53.28% of the compound's mass will be due to oxygen. Now let's apply that. How could we apply that? A sample C6H12O6 has a mass. I don't like to use the word weighs. Has a mass of 25.0 grams. How many grams of carbon are present? Hydrogen, oxygen. All right, so I want you to understand the scenario. I've got a sample of like sugar. All right, this sample weighs 25.0 grams. I have already determined that no matter what size or mass of the sample I have, 39.99% of that sample will be carbon. So the mass of carbon in the 25.0 gram sample of C6H12O6 is equal to the 39.99% divided by 100% equals 0.3999 times the mass of the compounds. So if I take 0.3999 and times it by 25, I get, so should have 3 sig figs, I get 10.0 grams of carbon. So what does that mean? That means in our sample of C6H12O6, in our 25 gram sample, 10 grams of it is due to the carbon that is present. The mass of hydrogen in the 25 grams of the compound, well, I need to get the percent of hydrogen, right? Right here, I see that no matter how much of the compound I have, 6.727% is hydrogen. So 6.727% hydrogen divided by 100% equals 0.06727. All right, and then we multiply that by the 25 grams, and what we get there is a very small number, 0.06727 times 25 equals, and with sig figs at 3, that gives us 1.68. All right, always label your answers. What is this 1.68? It is 1.68 grams of what? Grams of hydrogen in the 25 gram sample. All right, let's do the last one, and that would be the mass of oxygen in the 25.0 gram sample. All right, okay. We need the percentage. We know that 53.28% of the sample mass is due to oxygen. So let's take the 53.28% divided by 100. We get 0.5328. We multiply that by the mass of the sample, and we should get a little bit more than half, maybe 13. 25 times 0.5328 equals, look at there, guys, 13.3 grams. Grams of what? grams of oxygen in the sample. And what can we do to check our answers? Right? We have a 25-gram sample of the compounds. According to our math, 10 grams is carbon, 1.68 grams is hydrogen, and 13.3 grams is oxygen. Should those not add up to 25? Let's see. 10 plus 1.68 plus 13.3, 24.98, rounded to 3 sig figs, equals 25.0 grams of our compound. Okay, percent composition by mass, mass of the element divided by mass of the compounds. We can use that to determine the mass of an element in a sample of a compound. We could take this many different directions, sort of, okay? Great, I'm going to go ahead and end this. I actually need to get to homeroom. Bye.